Now, a reaction mechanism is a step-by-step operation that a reaction goes through in order to reach its ultimate goal. In this reaction mechanism, we have two steps, step one and step two. Each of these are called elementary steps of the chemical equation, or of the chemical reaction. So elementary steps or elementary reactions. So step one and step two are the mechanism by which this reaction takes place. So what is the overall reaction? Well, the overall reaction has to be a sum of the steps. So if we were to think of this in chunks, so over here we've got our reactants of both elementary steps, step one and step two. Let's go ahead and list them in one reaction. Let's assume that or let's pretend rather, that they're all reactants. So H2O2 and another H2O2, we could write as 2H2O2 plus I minus plus IO minus. So now we can do the same thing with our product side. Let's pretend they're collectively together. We've got an H2O and another H2O, so that's two waters, plus an IO minus, plus I minus, plus O2. So this is just us kind of thinking, but this would be our overall reaction before we've simplified anything down. If we notice, you've got an I minus on the left side and an I minus on the right side. You've got an IO minus on the left side and an IO minus on the right side. Just like in algebra, you're going to cancel something if it's on the left and the right side of a reaction. So, or you can even think of it like an equation now. You cancel the spectators. This I minus is going to cancel on both sides. The IO minus is going to cancel on both sides. And then you're left with 2H2O2 breaking into two H2Os plus an O2 molecule. So this would be, in this situation, our overall reaction, and you'll notice that it's balanced. This up here, the step one and step two, are merely the mechanisms by which this reaction takes place. This H2O2 reacts with this iodine to form this middle step of the reaction, which then allows step two to occur. So if we were to analyze this a little bit further, let me clear some of this up. Okay, you'll notice on step one, the H2O2 plus the iodine ion react to make water and IO with the 1 minus charge. Then that IO is immediately consumed in step two. Since this IO is produced and then immediately consumed within this reaction, it's called an intermediate. So the intermediate is formed in one step of the reaction mechanism and then immediately is consumed in a further step. For that reason, since it's produced and then consumed, it doesn't actually exist at any discernible amount, so it's not going to appear in our overall equation, but it did exist for a moment. Also, we canceled out this iodide ion, which was present at the beginning of step one, and then present again at the end of step two. Something that's present both at the beginning and at the end of a reaction mechanism serves as a catalyst for this reaction. The iodine ion isn't consumed at the end of the whole entire reaction. It's just consumed in step one, then immediately returned to its normal state by the end of step two. So this is just one example of a reaction mechanism, but overall, the elementary steps will form the overall reaction, and you can identify an intermediate by it being created then consumed, and you can identify a catalyst by it being present both at the beginning and the end of the chemical equation.